Assalamu alaikum. I am Sumbul Zehra from Sir Syed Government Girls College. With the support and guidance of our worthy Principal Professor Khalida Parveen, today I am here again to deliver a lecture on electric field intensity due to a long charge conductor. Today we will study what is electric field, what is electric field intensity, and what is the value of the electric field intensity if we place a long charge conductor in it. So first of all we will study what is electric field. The concept of electric field, whenever we place a charge anywhere, then we have studied it has a characteristics to attract other charges, and that means if here is one charge and we place another charge in its vicinity, then it will experience a force. Whenever we leave a charge particle, it will experience a force and it moves. So we can say there is something in that place which is pushing this particle to another place. What is this something is? Which is applying force on a charged particle. So we all know that only another charged particle can apply force. That means there is an effect of another charged particle in this space. So all this space where this is showing their effect is known as its field. So we can make a definition of field. Electric field is an effect in the space due to which a charge experiences a force. What is electric field intensity? We have already studied that electric field is an effect in the space due to which a charge experiences a force. This electric field is very strong at some point, very light, not there, or very much there. But how do we know that property is known as electric field intensity? So intensity is how much intense. How do we measure intensity? So the answer is intensity is measured by force. So we can define electric field intensity as intensity of electric field at a point is measured by force being experienced by a charged particle placed at that point. Suppose we have considered a charge Q and we have put this charge in a space. Now we will see whether this particle remain here or it experiences a force. Now suppose it experiences a force in any given direction. This force depends on two things. Number one, larger is the charge on this particle, more is the force. So force is directly proportional to Q, जिसको आप equation 1 कह दीजिए. Now I take equal same charge at one place, it experiences a force. Now take the same charge at another place, it experiences larger force there. So then we can say if the charge is same, then why is the force more at one point and less at another point? So the answer is intensity is at one place is less and intensity at other place is more. Then take the same particle at the third place at some point and the force is 0 here. So we can say there is no electric field, therefore force is 0. So the intensity of the electric field is directly proportional to force. So F is directly proportional to E. Now combine these two equations, then F is directly proportional to QE. So F equals to K. If we take out the proportionality sign, then F equals to K QE. So E equals to K F upon Q. If we take 1 coulomb unit charge and place it at any given location and it experiences a force of 1 Newton, then intensity is 1 unit. Or we can say force per unit charge that gives the intensity of electric field is known as electric field intensity. Now we will calculate electric field intensity due to a charge long conductor. This conductor is very long, means infinitely long on both sides. Then how can we measure the charge? We have discussed before that whenever we have charge distribution the length, then we cannot use the term total charge on the conductor. We use the term charge per unit length, and this conductor has charge per unit length which is lambda. So lambda is the charge per unit meter, that is linear charge density. Now we consider there is a point P at a normal distance r, and we are supposed to find out electric field at this point. So we cannot apply formula Q over R square because here Q is not a point charge. Q is not a complete charge which is located here, so we cannot use formula Q over R square. But because another reason is Q is distributed all over the conductor, and from here distance R is different at each and every point. So this formula is failed and we don't have any other formula. So we apply Gauss theorem which we have already studied, and this will make it easy. So the first condition for applying Gauss theorem is we have to consider an imaginary Gaussian surface, and the condition for Gaussian surface is symmetry. So for this, what will be its symmetrical surface? Answer is, if we wrapped a cylinder, then all the points are at fixed distance, and every point electric field is same. So there is one symmetry. This point of the surface is at a distance r. Because the distance is same, then electric field is symmetrical. Whatever will be the electric field, but it will be symmetrical at all the points. Where is the angle A? There is a surface area, and normal to this its area vector ds, and the angle between area vector and electric field is known as angle A, which is 0 at the curved surface at all the points. So this is a perfect Gaussian surface. Now for upper and lower sides, their area vector ds and electric field has got angle 90 degree. They are perpendicular to each other, so it is not completely symmetrical. But we will say that when we cannot imagine one surface which is completely symmetrical, then we divide our Gaussian surface into two surfaces so that each surface has got separate symmetry. So now we consider about the curved surface. They do have symmetry. Inside a curved surface, at every point electric intensity is symmetrical. At every point theta is symmetrical, r is same, theta is 0 degree. This is for curved surface. Now for flat surface, angle is 90 at every point angle, so there is symmetry. Then flux is phi equals to EDS cos theta. Then phi is 0, so at every point flux is 0. So we don't have to do much calculation for upper and lower surface. We have to take this whole surface as a Gaussian surface, but when it comes to calculation, we will do our calculation in two parts. One for the curved surface because curved surface has a symmetry, and one for the flat surface because flat surface again has symmetry. This is what I told before. If we are compelled that one surface we are not getting which is symmetrical, we will divide our surface into two parts, and each part should have a separate symmetry. But every point should be symmetrical in that part. So in curve every point has symmetry, in flat every point has symmetry. So purposely I have divided into three surfaces, one curve, one flat top, one flat bottom. So when we are doing calculation, I will do it in three parts. First, point P lies on the surface where electric field at every point of upward surface is symmetrical. Theta at every point of curved surface is 0, and at every point of flat surface it is 90. Now second point is we have to apply Gauss theorem, which tells us that close integral E dot ds equals to close integral E ds cos of theta. Now we divide this close integral into three parts. Close integral E dot ds equals to close integral E ds cos of 0 degree for curved surface plus close integral E ds cos of 90 degree for top flat surface plus close integral E ds cos of 90 degree for bottom flat surface. And we know that cos 90 value is 0. So close integral for top and bottom flat surface is 0. We are only left with curved surface. And we have known that electric field intensity is constant everywhere. So we can take out of this integral, and E integral ds is for curved surface. And now suppose we have taken a conductor of length L, and the total area of this cylinder is 2 pi RL. So value of integral ds becomes E 2 pi RL. Now we have to check charge within the surface, Gaussian surface, which is equal to lambda into L. Lambda is the charge on 1 meter and conductor is 1 meter long. So Q equals to lambda into L, which is the charge enclosed within the Gaussian surface. Now apply Gauss theorem, which tells us that close integral E dot ds equals to Q upon epsilon naught. Putting the value of close integral E dot ds, which has value E into 2 pi RL, and value of charge is lambda L upon epsilon naught. L से L cancel. So electric field intensity value is lambda upon 2 pi epsilon naught R. So this is the value of electric field intensity due to a long charge conductor. So if we know the value of charge density and distance r, we can find out the electric field intensity value. Right. So that's all for today. Thank you so much.